All right, welcome everybody. Today we're going to start a little bit early so there's time for me to share with you an incredible achievement of one of your peers in COMP110. I was informed today that a turtle project, oh, hold on, I gotta wait until the sound is on this. So I'm actually going to switch it over to Ibrahim's TikTok, and we're going to start the class with that rather than our normal hype music that we just started with. Without further ado, the world's greatest TikTok ever made.
You guys are about to witness over 15 hours of my hard work on this coding. My comp sci class, ladies and gentlemen. Here we go. Here we go. Watch this. Watch this. This is all code. All code. Look at that. Look at that. Look at that. Oh. There's the stars. There's the stars. Yes. Go, 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 go. Hold on, hold on. You guys haven't even seen the best part yet. Hold on. Hold on. Wait, wait, wait. There's the windows. There's other windows. There's the circles. Snowflakes. Here we go. Here we go. Wait for the best part. Wait for the best part. Watch this. There's a snowman. There's a snowman. There's another one. There's another one. There's another one. Ooh.
That might be the greatest thing I've ever seen. I hope you all enjoyed that as well. The account to follow on TikTok is Ibra_shock. Highly encouraged. This is one of your peers in COMP110. 250,000 views, and this is the first thing that's ever gone viral in 110. So super exciting day for the class. We were very impressed with the projects you all put together on the turtle scene demo, and we've put together the MODA. Your fantastic TA, Esri White, did some programming to take the submissions that you all made to generate this page, to download all the images, and applied some computer science to make this page come to life. And we had over 100 submissions that are all uniquely fabulous in their own way, and would highly encourage you to sort through these, appreciate the art of the peers in your class. And what I want to say is if yours didn't look quite like any of these, that's totally fine. Mine wouldn't have either. This is a level of artistry well but beyond anything that I could have done or would have expected to come out of this project. So really excited to see that work that you all put forth. The exercise 4 deadline was extended to Saturday to give you a little bit more time to breathe. I know that office hours queues were a little bit longer today than normal, and I imagine tomorrow you've got some time in office hours as well. There won't be any office hours on Saturday. This is just de facto, but if you're waiting until Saturday, give yourself some time to be able to work through it on your own. I think the best way to practice on this particular problem set, which was a quiz, is really to just try and force yourself to think through the steps that you think you need to take and think at a very granular low level. This is great practice for the unit that we're going into, looking at sequences, and we looked at some data structures called lists, as well as tuples and ranges in the previous lesson. And today we're going to be looking at some new syntax that actually simplifies our lives and that I think you're going to love using compared to the while loops we're coming from in the cases where you can use it, called for-in loops. Before I get there, a couple of other quick announcements. We're going to have a little bit of synchronous activity today. There will be a grade scope assignment for this lesson, and you'll be working on that in breakout rooms as we get to a challenge question. And then after that, there's going to be a tutorial that's a follow-along tutorial where you'll get to build a simulator that will simulate what's called a stochastic process. And we're going to be focusing on the probabilities of rolling dice and simulating hundreds of thousands of trials rolling dice. And I think this is a lesson that hopefully gives you a feel for how to attack problems that you have no clue where to start. And I think understanding some strategies for getting started on programs is something that we're hoping to work with you on in this lesson and as well as in tutoring moving ahead. We will have tutoring tonight. Tutoring in the first hour is primarily intended for folks who have some prior experience. It's the 1 hour of the week that we can answer some of your more advanced questions. And then generally, tutoring is open to anyone, and all comers for the closing hour of the evening. This weekend, we're going to try and put out a survey that will ask a variety of questions, both in terms of how the course is going so far, some questions about what you think about synchronous versus asynchronous material, how the houses are going, ideas that you might have for improving the house experience and what we could do to allow you to make more connections with your peers, as well as some wild and crazy questions that we've come up with, because I think one of the next projects we're going to do is some data analysis on you and your peers. We will anonymize the responses so you can't track anyone's data back to themselves, and we'll have some fun trivia style questions that we can try and analyze with both statistics and some plotting. I think that's all for the announcements, so we're going to jump right into our lesson for today. There's a common pattern when you're trying to loop through every item in a sequence. And you've seen this with a while loop, right? So let's take a look at iteration using a while loop, where imagine here we've got a sequence that I've named SEQ for short that's meant to be generic, although in this example, we are assigning a range to it. And that range is going to be odd numbers, starting from 1 going up to 100, not inclusive, and we're counting up by 2s or stepping by 2s each way. Right, so we briefly introduced the idea of a range in the previous lesson, and this is our start, stop, and step. And so the idea of this loop that's now hopefully becoming a pretty familiar pattern when you're trying to write a loop that runs some number of times is really highlighted here, where we're saying, okay, we need a counter variable, and we'll start from 0 because that's typically where we start counting from. And we are going to loop while that counter variable is less than the number of times we want to loop, because we're starting from 0, right? And at the end of each loop, we're going to increment that counter by 1. Inside of the loop, we can specially set up a variable that's special and pulls out the item that we're trying to work with in the sequence that we're trying to iterate through. So here, notice we're saying, take the sequence at index I, which would start at 0 and then 1 and then 2 and 3 and 4, and assign that to a variable named item inside of this repeat block. We've commented out, and we're assuming that you're going to do something interesting with that item inside of this repeat block. And this pattern is effectively giving you the ability to move item by item by item through any sequence, right? Because remember, sequences are indexed, ordered items that are collected together in a single value. And here we're using a range sequence, but we know that lists are sequences, tuples, and strings are all sequences as well. So the idea of iteration is we're looping towards some goal. We want to stop looping at some point, and we're trying to move item by item through a collection of values that we want to process. And this pattern is so common that you want to process every item in some collection that Python and many other languages have some special syntax for it, called the for-in or a for-each construct. And so on the left here, you're seeing the current code that we would need to write to process every item in some sequence. And what you're going to see on the right is a modified version of this that uses the for-in syntax. And the first thing you should notice is, wow, there's a lot less code that you need to write and worry yourself over in order to use the for-in syntax. Notice we're setting up the same sequence, and then all of the logic for iterating through each item in our list is contained in this starting line of the for-in. And what we're saying is for, and then there's sort of this implicit each, right? You would never write this in Python, but you would say and think for each item in the sequence odds, in this case, or in the collection odds. And what this has the effect of doing is setting up a list that, just like a while loop, this whatever is indented here in the repeat block is going to be repeated, and it's going to be repeated for every item in the list. Inside of the list, item is going to be assigned the next item of your sequence that's going to be processed. So just like we set up in the while example here, an item variable as the first step of working through each item in our sequence inside of a while loop, that is happening automatically behind the scenes. And so you're actually declaring a variable here. And we could name this whatever we wanted. We could say for odd in odds, and we'll try this out in just a moment, or for letter or character in string. This is a variable name that we get to decide as the programmer. And the programming language is automatically assigning to this variable the next value from our sequence as we're working through it. Okay, and so this is a much simpler syntactical structure for moving through every item in a sequence. You'll often hear this called in other languages for each, and there will be some syntactical differences, but this is such a common pattern when you're trying to write algorithms that move through a sequence of data and need to touch or process every single piece of data in that sequence. It's a very common pattern. There are some other types besides sequences that this pattern will apply to, but we're not going to worry ourselves with those. Once we get to those types, we'll mention that you can use the for-in syntax with them as well. For now, just know that these work with sequences, so you can use this with strings, and each item will be a character. And with lists, each item will be whatever value type is in that list, and so forth. So I think it's worth taking a quick stab at playing around with one of these. And I'm going to go ahead and start up my Python REPL. And let's try this with a string. We know that a string is a sequence. So maybe we set up a string such as name, and my name is Chris, right? And you can enter your name. And so we've declared our variable name. And we'll try writing this for-in construct, right? So for, and then I might write character in name, okay? And this will kick off a new block. And so when you are working in the REPL in this way, when you see those 3 dots, that's an indication that, hey, you should indent by some amount. So I'm going to add 2 spaces here. And what do we want to do? Well, we want to print out, in this example, we're just going to print out each letter or each character. So print character, right? The key thing to recognize is as this loop will, when it gets evaluated, first it's going to see, okay, are there any items in name to process? And it's a sequence, so we check and see what are the items of the sequence, and it's a string that has 4 characters in it. So the first time this loop runs, character will be the letter K, or the index 0 of this particular string. The second time it'll be R, the third time I, so on and so forth. Right? So when we evaluate this, notice that each item in our sequence, each of those characters in this string, printed on its own line. And we could try this with a range as well. So for, let's say, I in range from 0, we'll do this, the example we had in the slide. So from 1 to 100, count up by 2, that's our step. And we can once again print I. Right? And oops, that caused it to go off my screen a little bit faster than what I would have hoped. So this was the for-in that we wrote. And notice we've got a sequence here. And as long as that, the value that follows the in is something that is a sequence or otherwise iterable, then this construct will work. And so here we were able to use that same syntax to loop through each item in this range. And that went from the start to end. And notice because we're stepping up by 2s, these were the odd numbers. And so this is a really handy pattern. If you want to generate some numbers and loop through those numbers in a pattern, you can do something like this. The last example I want to give is just sort of playing around with this, is we can, from typing, import list. So we're going to try setting up a list here, and I want to do this in a way that is demonstrates how we strongly type our lists. And maybe we'll set up a list of names. That will be a list of strs, and a list of string values. In well, you can use list literal syntax here to construct a new list that has some names in it. So Chris, Esri, and Kaki, right? So I've set up my list of names, and now if we wanted to write an algorithm that moved through each of those names, or write a loop that moved through each of the items in this list, we can set up a for name in names list. And again, this variable name that we're establishing here is, we can choose whatever we want. I could have said for item in names. And what that means is, inside of this loop block, we can now use the word item, and I might use hello, and then concatenate item, right? So the ability for us to use this variable name item inside of the repeat block is based on us deciding to name this variable as part of this for-in syntax. So we're declaring in sort of a special way a variable here that each time this repeat block is evaluated, it's going to be updated to be the next and assigned to be the next item in this names sequence. So we evaluate this and notice we print out hello Chris, hello Esri, hello Kaki. All right, so those are 3 examples, and just trying to drive home this idea that we can use this with any sequence. So we could use this with a tuple too, but I'm not going to demonstrate that here. All right. So a couple of quick semantics before we go to a challenge question. In the repeat block, this identifier, which we get to choose using it's just a variable that you're declaring here, and in this special way, you choose its name, and it's going to be assigned to the next value of iteration. The main thing to recognize with this pattern versus a while loop is that it simplifies the code that you need to write in order to process every item in some sequence. But it comes with the sort of constraint that you are going to loop through each item in the sequence, right? You don't have as much control over your looping pattern as you do in a while loop. So there are many algorithms that you can't write with a for-in loop. You can't use this everywhere. If there are special patterns you wanted to apply to your counter variable, which we'll see if we were writing sorting algorithms or search algorithms that were more powerful, we would need much more control over how we moved through the data in our list or our sequence than we have with for-in. But if you're writing a program that needs to move through every single element one by one by one by one in some list or sequence, this syntax does come in handy, and it also helps you avoid errors like forgetting to increment your counter variable, which can lead to an infinite loop and other things. So there's trade-offs here. You have a little bit less control over your loop, but because 80% of the loops that we're going to write in this course wind up having to move through every element in them, this is very handy to know and can help you avoid some bugs. All right. So with that said, I want to move to a challenge question, and I want to set up the prompt for this question and then give you an opportunity to talk through this question with your peers in a breakout room that we'll move to once I've set it up. We're going to look at not only for-in loops here, but also the idea of a nested loop. So let me explain this setup really quickly. I want to point out that we're setting up this message variable that's initially an empty string. And then we have a for-in loop that we just looked at, and we're using a range here. And the range starts at 1 and stops at 3. Then we're nesting. So notice that the indentation here is very intentional. This isn't an accident. We are intentionally indenting all of this by 1 level and by a second level for the second for-in. So we have the second for loop that is a for some variable in some other range. And notice one thing that you'll want to reason through with your group mates is what is the significance of there being a variable in that range. And I want you to try imagining you're the computer and thinking through this in a very intentional step-by-step way. Keep track of the variables I and H as well as message. And there are a few questions on Gradescope to begin thinking through and responding to with your neighbors. Let's spend about 5 to 8 minutes on this, and TAs can go ahead and take it away from here. One more minute. All right. So as folks are returning from the breakout rooms, I want to begin talking through some strategies for thinking on a for loop like this. And one of the key things to do is keep track of your variables. And typically, if we saw some code like this in the middle of a full-on environment diagram, we would have some frames set up. This would be happening inside some context of a frame. So I might just sort of loosely set up a frame here, and we're just going to assume this is in some function in our program. And we've got this message variable that's set up. So I'm going to set up message, and we'll keep track of that. And then we're going to, when we reach this for loop, we're going to have an I variable that we need to establish, and we need to keep track of it. But we don't yet know what I is. So I is going to be related to the sequence range from 1 to 3, right? So the sequence range 1 to 3 has a starting value of 1, and that will be the first value assigned to I, right? So I is initially 1, and I should have just said message is the empty string. I'm just going to leave double quotes here unclosed because we can kind of get the hint that we're about to extend and concatenate to the message variable here, and we'll close it out when we're done with it. But we're starting I out at 1, and we can convince ourselves, sure enough, like if we're going from 1 to 3, we know that 1 is the starting value, and the step is by default 1, so we know we're gonna have to go to 1, 2, and we're not gonna go to 3, right? But because the stop of a range is not inclusive, it's exclusive. Okay, but we're gonna have to, we'll wait, we've gotta come back. We're getting a little bit ahead of ourselves by thinking through that, but the main thing to know is that we need to loop or go into the body of this for in loop at least one time. And the first thing we see happen is we concatenate H to our current value of message, which adds this character H to it. And then we reach another for in, and this is where we establish the variable H, and H is initially 0. I at this point was 1, so this range, I might just scribble off to the side here, range from 0 to 1. And we know that 1 is not going to be inclusive, so this is only going to loop for where H is going to be 0 one time. So what do we see happens here? Well, we increase, or we concatenate E onto the end of this message. And when we reach the end of a loop, whether it's a while loop or a for in, we go back up to the top of its most connected, of the loop it belongs to, right? We just finished this for H in range, and now we need to see, do we need to loop again in this inner for loop? That needs to complete before we loop in the outermost, right? It's as if, you know, we've got to complete this loop before we complete the outermost loop and go back up to it. So we ask, is there another thing we need to do in this range? H is 0. If we were to increase H to be the next item, well, there is no next item because 1 is not inclusive. All right, so we're done with this inner loop for this iteration. And now we go up and we ask, okay, is there another value of I? I is currently 1, and is there another value in the range between 1 and 3 that would be what we would assign to I that we need to process in the sequence? And yes, 2 is what is going to be the next value of I. We go into this loop again, and we add another H to our message by concatenating it, and then we reach this for in again. And we would reset our variable H to be whatever we're starting from the second time we reach this for loop. So in this case, back to 0. But this time around, the range is from 0 to 2, right? So we know that we're going to have 0 and 1 as items, and we're not going to include 2 in our iteration, right? So we go into this loop and we concatenate an E, okay? And now here's where this is a little bit different the second time this loop iterated, and would be different in the future as well if we went higher than this. But now we're asking, is there another value of H that we need to process? Well, we're currently trying to work through the sequence that is the range 0, 1, and then we're not including 2. So yes, we need to have an H value that is 1, and we still need to process the value where H is 1. So we concatenate E to our message again, and we reach the end of this innermost loop. So we go back and we ask, is there another value of H that we need to process? And if we were to increase H to be 2, we would see that no, that's the stopping point. We're only moving through the sequence while H is less than 2. So we're done with that innermost loop. We would go back up to our outermost loop and we would ask, okay, is there another value of I that we need to process? Well, I's value, and we can get rid of H at this point if we wanted to, since it was nested, but I's value is 2. And we're asking, okay, in the range of 1, 3, where 3 is not inclusive, is there another value of I we need to process? That answer would be no. We would continue on, that loop would be complete, and we would print out the string. And we would have the string he with 2 H's and 3 E's organized in this way in our message. And you can imagine that this pattern where if we had 4 or 5, one of those numbers up there, a much bigger number, we would have increasing number of E's after each H. And I would encourage you to play around with this if you have questions, and stick around in your Zoom if you have questions about this specific example to talk through with TAs. If you don't have any questions about this example, I'm going to turn you over to the asynchronous content today, which is on the course site, and you'll see it. Let me just clear the screen here. You will see this on today's lecture materials, and you can go ahead and get started with that tutorial if you're good to go on this. The key takeaway for nested loops is you have to be sure to complete the innermost loops before you worry about going back up to the top of an outer loop. That's all we've got for today. Stick around and ask questions of your TAs about this nested looping if you've got questions. Otherwise, enjoy today's tutorial, and I hope you all have a wonderful weekend.